Hello, this is Geometry, Notes 11 for Part 1 on Areas of Composite Figures by Mrs. Moslick. Please start working on the warm-up, ACT number 35. Find the area of the trapezoid, round to the nearest square foot. Pause this video as you work through the problem. Now, you need to make sure that you understand that to find the height, you either will use SOHCAHTOA or the L's. The L's are just a lot faster. Opposite 45, the special right triangles. Opposite 45 is your L. Opposite 90 is L square root of 2. So start with your L square root of 2 equal to 10 and solve for L. So you got your L square root of 2 equals 10. You don't have to rationalize the denominator because we're going to be using this in our problem. However, since we're going to be using this a lot, it will be a lot easier to use this simplified version so that we don't have problems with our calculator with all of the parentheses of 10 divided by the square root of 2. So I'm rationalizing the denominator, and we find out that L turns out to be 5 square root of 2 simplified. A lot easier to use that. Okay, so now we know what the height is. That's L is 5 square root of 2. Note that the base includes a 10 and an L, so it's going to be 10 plus 5 times the square root of 2. So the area of a trapezoid is 1/2 height times the sum of the bases. You could also use this problem in your solution as using areas of composite figures. For instance, you can think of this as the area of the yellow triangle plus the area of the green rectangle. But instead of summing up those two separate areas, I am just going to use the area of a trapezoid formula. Go ahead and pause this video if you have not finished this problem yet. When you are done finding the area rounded to the nearest square foot, then go ahead and unpause with your red pen, make any corrections. So the answer for area rounded to the nearest tenth of a foot is 95.7. However, the question asks us to round to the nearest square foot. So our final answer is 96 square feet. Whether we use the area of a trapezoid formula, which I did, or you could have used the area of a triangle plus the area of a rectangle. Now let's get into today's lesson. Today's lesson is on composite figures. That means figures that can be broken into smaller shapes, including parallelograms, rhombi, rectangles, squares, trapezoid, triangles, circles, and semicircles. So this first example, that warm-up, was actually a composite figure made up of a triangle and a rectangle. When you're finding areas of composite figures, you're going to find separate areas, and then you're going to add or subtract those areas to get a total for the composite figure. The biggest question you have on these problems is, am I going to add or am I going to subtract? So let's go to example 1. And when you look at example 1, ask yourself, am I going to add the area or am I going to subtract them? So we will subtract the area. So the area of our shaded region, and we'll write it as area of shaded, equals the area of the rectangle minus half of an area of a circle. So this is a subtraction problem. So to think about the area of the circle, we need to figure out what the radius is. And in that case, we're just dealing with the radius is half of 30, which is 15. Go ahead and write down your formulas for area of a rectangle, which is base times height, and your area for a circle, and just multiply 1/2 times that. So area of a circle is pi r squared, and then go ahead and plug in your particular numbers. So our base is 50, and our height is 30. For the rectangle. The radius we already talked about is half of that 30, so our radius is 15. Go ahead and put that in your calculator. It does not say how many decimal places to round, so we'll just round to the nearest thousandth. Go ahead and put that in your calculator. And your answer is approximately 1,146.571 square feet. Example 2, are we going to add or subtract areas? That's right, we're going to subtract the areas. So our area of our shaded region, so we'll write down our equation. So this is required. The area of the shaded region is the area of the rectangle minus 3 times the area of each circle. And each circle has a radius of 5, but what are the dimensions of your rectangle? Think about it. Excellent, class. You are correct. They are 10 by 30 are the dimensions of the rectangle. So now we write down our formulas. So the area of the rectangle is base times height, and the area of each circle is pi r squared. So we have the base is 30, the height is 10, and each radius is 5. Go ahead and put this in your calculator. Again, it does not say how many decimal places to round to, so we will round to the nearest thousandth. Go ahead and put that in your calculator. And the correct answer is indeed 64.381 squared centimeters, rounded to the nearest thousandth. Let's try the next one. Are we going to add or subtract the areas? You are correct. We are going to add the areas. So the area of the shaded part, we'll write this down, it's kind of like an essay in Com Arts class where you have to give me your introduction first, and then we'll put in the particular formulas. But I need the general idea. What am I adding? What am I subtracting? And we are going to be adding the rectangle with half of the area of a circle. So now figure out what the radius is. Excellent, that is correct. The radius is 7.5 feet. So we're going to now plug in our particular numbers. Sorry, not the particular numbers. We have to write down our equation first. So we have area of a rectangle is base times height. And then the area of a circle is pi r squared, but we have half of a circle, so it's 1/2 pi r squared. So we have 34 by 15 plus 1/2 times 7.5 squared. Go ahead and put that in your calculator. Round to the nearest thousandth because they don't tell us anything else in this problem. And the correct answer, rounded to the thousandths place, is 598.357 square feet. Let's look at the last problem and figure out if we're going to be adding or subtracting and which shapes we're going to add or subtract. Okay, so you guys are right. We're going to be adding 2 trapezoids. So we're going to write down our formula. Area of the shaded part equals 2 times area of a trapezoid. So 2 times area of a trapezoid. Now you could either write out the word trapezoid or just use the symbol for a trapezoid. But what I need you guys to do right now is take some time and tell me what the height of each trapezoid is and what the base 1 and the base 2 are for the trapezoid. Now remember, base 1 and base 2 could be mixed around because we have the commutative property of addition. It doesn't matter if we have B1 plus B2 or B2 plus B1, those are equal to each other. And again, you guys are correct. Half of 64 is the height of each trapezoid. So now we are ready to plug in numbers, but we have to make sure we write down the formula for a trapezoid. So we have 2 times the area of a trapezoid is 1/2 height times the sum of the bases. And remember, that formula comes from if you take any trapezoid and you connect the diagonal of the corners, the opposite corners of one of the opposite corners, and you have just created 2 triangles. So that's where that formula comes from. You can either multiply out the 2 times 1/2 right away, and you're left with height times the sum of the bases and then plug in numbers, or you can just keep that 2 times 1/2 there and then just simplify it all in your calculator at the end. So go ahead and plug in numbers for H, which we know is 32. B1 and B2 can be either 20 and 40 or 40 and 20. I just chose 20 for B1 and 40 for B2, but it's completely up to you what you want to use. So go ahead and write that down. And then just pause the video for a little bit. When you're done with your final answer, go ahead and unpause the video. And our final answer for this set of notes is 1,920 square meters. Hope you enjoyed this lesson. It's a great review lesson of all of the equations of circles and other quadrilaterals and other shapes that we've had for areas. And so this just is a great summary. If you're going to add or subtract them, you get to decide by the look of the picture and review your concepts. Enjoy your homework, and if you have any questions, just look back on these notes and feel free to go back and re-look at the notes. Have a great day. Bye-bye.